Probability first exercise. Complete the following statements. First one, probability of an event and event E plus probability of the event not E. Event E plus not E, which is equal to 1. The probability of an event that cannot happen. So we can write that as 0. Probability of an event that cannot happen is 0. Such an event is called impossible event. Impossible event. The probability of an event that's certain to happen, sure to happen. Then the probability is 1. Such an event is called sure event. The sum of the probabilities of all the elementary events of an experiment is always 1. The sum of the probabilities of all the elementary events is equal to 1. The probability of an event is greater than or equal to, greater than 0, equal to 0 also can happen, and less than or equal to 1. Probability lies from 0 to 1. Lies between 0 and 1. If the probability is 0, which means impossible event. If the probability is 1, then that's called sure event. Second question. Which of the following experiments have equally likely outcomes? Equally likely outcomes. Explain. A driver attempts to start a car. The car starts or does not start. It depends the driver and depends the condition of the car. It's not equally likely. So to that particular event, the car is not good, then more chance to not to start. If the new car is good condition, probability sure event to start. So that is not equally likely. Second, a player attempts to shoot a basketball. She or he shoots or misses the shot. That also particular event which is not equally likely. If the player is good in that, then more chance to win or to shoot. Third one. A trial is made to answer a true or false question. It's a trial. So not the child doesn't know the answer, just a trial. So the answer is right or wrong. That equally likely. Here a baby is born. It's a boy or girl. That also equally likely. So we can write 1 and 2 not equally likely. 3 and 4 equally likely. So here we can write the explanation as for the second question. 1 and 2, first 2 events can be favorable to particular event. Depends the car, depends the person. So it depends many factors. Therefore, that is not equally likely. But third and fourth statements are events are equally likely. Both have equal chances to happen. That's the explanation explained. So explanation of that question. Question number 3. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? We know that when we toss a coin, the outcomes can be head or tail. Head or tail. These two are equally likely to occur. So the result is completely unpredictable. That's why for each game before starting, tossing the coin. So tossing a coin is equally likely, equal chance to occur head or tail. Now question number 4. Which of the following cannot be the probability of an event? So B. It's a negative value. We know that probability of an event cannot be negative. That lies between from 0 to 1. can equal to 0 or greater than 0, can equal to 1 or less than 1. So negative number is not coming here. That's why option B is correct. Next, fifth question. If P of E is equal to 0. Here it's given P of E as 0.05. What is the probability of not E? So P of not E, not the event, which is equal to 1 minus P of E, which is equal to 1 minus 0. P of E is given as 0.05, which is equal to 0.95. Sixth question. A bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy? Here it's given a bag contains lemon flavored candies only. So from that bag we cannot take any orange flavored candy. So the probability will be to get an orange flavored candy, that is 0. There is no orange flavored candy, so the probability of an orange flavored candy, that means P of that event, P of E is equal to 0. Then to get a lemon flavored candy, all candies are lemon flavored, so the probability to get the lemon flavored candy, that is equal to 1, sure event. So all candies are lemon flavored in the bag, so the probability of a lemon flavored candy, P of E event, is equal to 1. This is a sure event and this is an impossible event. Question number 7. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. Not having the same birthday. What is the probability that the students have the same birthday? So we know that P of E plus P of not E is equal to 1. From that we can write P of not E is equal to 1 minus P of E. Here P of E, we can take P of E, that is the given event, probability is 0.992. So what is the probability that 2 students have the same birthday? So we have to minus that, not E, which is equal to 1 minus P of E, that means 0.992, which is equal to 0.008. So that is the probability that the 2 students have the same birthday. So we can write, therefore the probability that the 2 students have the same birthday is 0.008. Here it is given the probability of 2 students not having the same birthday, not having the same day, that is given as 0.992. So to having the same day means 1 minus the given probability. So the probability 2 students have the same birthday, that is 0.008. Question number 8. A bag contains 3 red balls and 5 black balls. So we can write total balls in the bag is equal to 3 red and 5 black. Total is 8. And a ball is drawn at random from the bag. What is the probability that the ball drawn is red? That means probability to get a red ball is equal to number of red balls, that means 3 red balls, divided by total number of balls, 8. So 3 by 8. Second part, probability of not red. Probability to get not red, that means total probability is 1, that minus to get the red ball. Probability of to get the red ball, 3 by 8, which is equal to 5 by 8. This by using P of E plus P of not E is equal to 1. Question number 9. A box contains 5 red marble, 8 white marbles, 4 green marbles. So we can write number of red marbles is equal to 5, white marbles is equal to 8, green marbles is equal to 4, and total number of marbles 5 plus 8 plus 4 is equal to 17. Now, one marble is taken out of the box at random. What is the probability that the marble taken out will be red? First one, the probability to get a red marble. To get a red marble, that means number of red marbles by total number of marbles. Number of red marbles by total number of marbles. Which is equal to red marbles here 5. Total number is 70. So 5 by 70. Now second part, white marble. To get a white marble. So probability to get white marble, which is equal to number of white marbles by total number of marbles. White is 8 by 70. Then third part, not green. So not green means probability of getting not a green marble. We can take that as using the same probability rule. Probability of the event plus not the event is equal to 1. So probability of not the event is equal to 1 minus P of E. So we can write here 1 minus P of E. That means P of getting, probability of getting green, which is equal to 1 minus. To get a green marble, that is 4 by 17. Number of green marbles by total number of marbles. 17 minus 4, that is 13. So the 13 by 17. Tenth question. A piggy bank contains 100 to 50 paise coins, 50 1 rupee coins, and 20 2 rupee coins, 10 5 rupee coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paise coin and will not be a 5 rupee coin? So the given terms we can write in the form of a table. 50 paise coins, that 100. 1 rupee coins 50, 2 rupee coins 20, and 5 rupee coins 10. So total 100 plus 50 plus 20 plus 10 is equal to 180. First part, what will be the probability? It will be a 50 paise coin. So here 150 paise coins, total is 180. You can write to get a 50 paise coin, that means 100 by 180. Which is equal to, when we are simplifying, 5 by 9 divided by 2. 5 by 9. Second part, will not be a 5 rupee coin. So we can use probability of E plus not E is equal to 1. Then not E is equal to 1 minus probability of E, which is equal to here 1 minus, what is the probability to get a 5 rupee coin here? 10 by 180. 10 by 180. So here 1 minus 1 by 18, which is equal to 17 by 18. So that is the probability not a 5 rupee coin. 11. Gobi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. So total number of fishes in the tank is equal to 5 male and 8 female. So 5 plus 8, 13 fishes are there. And what is the probability that the fish taken out is a male fish? So probability to get a male fish is equal to here 5 male fish. So 5 by total 13. So 5 by 13. Question number 12. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3 up to 8. In the figure it's given. And these are equally likely outcomes. What is the probability that it will point out each one? So here we can write the numbers are 1, 2, 3, 4, 5, 6, 7, 8. Probability of getting 8. Out of this, probability of getting that number is 1. Total 8 numbers are there. So 1 by 8 is the probability to get one of these digits. Then second, probability of an odd number. We know that odd numbers here one, 3, 5, 7. So 4 numbers are odd. So we can write 4 by total, that is 8, which is equal to 1 by 2. Then a number greater than 2. Except these two, rest of that 6 numbers are greater than 2. So we can write 6 by total is 8. It's equal to 3 by 4. Then a number less than 9. Here all the numbers are less than 9 from 1 to 8. So we can write all these numbers, 8 numbers are there. Out of the total is 8, which is equal to probability 1, 8 by 8. Question number 13. A die is thrown once. Find the probability of getting a prime number. We know that the outcomes of when the die is thrown 1, 2, 3, 4, 5 and 6. Then to get a prime number, from here the prime number, 1 is not a prime or composite. So then next prime, that is 2, 3 and 5. So 3 prime numbers are there. Total 6 numbers. 3 by 6, which is equal to 1 by 2. Then second part, a number lying between 2 and 6. Between 2 and 6. 1, 2, 3 numbers. So which is equal to 3 by total outcomes, that is 6, is equal to 1 by 2. Third part, to get an odd number. Here odd numbers 1, 3 and 5. 3 numbers. 3 by the total 6 numbers are there, which is equal to 1 by 2. Question number 14. One card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting. So total, a number of cards in a well-shuffled deck, that means 52. We know that there are 26 red cards and 26 black cards. Total 52. In red itself, 2 types are there. Heart and diamond. Black, that means spade and clover. So that also 2 types. Total 4 times are there. Then face cards means king, queen and jack. Based on that, we can write the answers. Probability to get a king of red color. In each set, 1 king of red color means 2 groups are there. So 2 out of 52. 2 by 52, which is equal to 1 by 26. Then to get a face card. 3 face cards are there. Like that way, 4 sets. 1, 2, 3, 4 sets are there. So 4 into 3. 4 into 3 is equal to 12 face cards are there out of 52. So 12 by 52, which is equal to 3 by 13. 3 in each group. 3 face cards in each set. Next, a red face card. So 3 face card here. Again the second group, that also contains 3 face card. Both are in red set. So total 6 face cards there. So we can write 6 by 52, which is equal to 3 by 26. 3 by 26. Fourth part, The jack of hearts. Only one card, jack in heart set, so 1 by 52. Then is spade. There in the set, 13, one set full is spade, so 13 cards are there, 13 by 52. Total is 52, so which means 1 by 4. Out of 4 divisions, one set full is spade, so 1 by 4. The queen of diamond. Diamond in one set, only one queen, so 1 by 52. Question number 15. 5 cards. The 10, jack, queen, king and ace of diamonds are well shuffled with their face cards. One card is then picked up at random. So here total 5 cards are there. So total number of outcomes, that is 5. Then the first part, what is the probability that the card is queen? So that is 1 out of 5. So we can write probability of getting the queen is 1 by total 5 cards only there. So 1 by 5. Then second, but if the queen is drawn and put aside, just remove that card. What is the probability that the second card picked up? That means keeping queen aside, removed from the set. Then after queen, just 4 cards only there. So total number of outcomes is equal to 4. From that 4, now Q is not there, only 10, jack, king and ace. These 4 cards are there. From these 4, we have to find the probability of getting an ace. Here out of 4, one card is that ace. So we can write 1 by 4. Then second part, be a queen. Probability of getting a queen. Here there is no chance to get a queen from here. There is in the outcome there is no queen. So no chance. That is not possible to pick a queen from these cards. So we can write 0 by 4, which is equal to 0. To getting or to picking a queen card from here, that is not possible, impossible. So that getting the probability as 0. Number 16. 12 defective pens are accidentally mixed with 132 good ones. So we can write number of defective pens 12, number of good pens, that is 132. So total number of pens is 12 plus 132, 144. Now one pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So the probability to get a good pen, getting a good pen is equal to, here 132 good pens are there, 132, and the total number is coming 144. This is equal to 11 by 12. So a lot of 20 bulbs contain 4 defective ones. So we can write total number of bulbs, that is 20, defective ones 4, which means non-defective ones, that 20 minus 4, 16 are there. So 16 good ones and 4 defective bulbs. Now first part of that question, what is the probability that this bulb is defective? If one bulb is drawn at random from the lot, then what is the probability that this bulb is defective? So probability of a defective bulb, here probability of defective bulb, that is 4 out of 20. So 4 by 20, which is equal to 1 by 5. Then second part, suppose the bulb is drawn in the first part is defective, is not defective and is not replaced. That means total 20 bulbs were there. Now it's not replaced. So the remaining is 19 only. The bulb is not defective and not replaced. Therefore total number of bulbs now are 19. 4 are defective and 15 non-defective. Out of the 16, 1 is already taken out and then not replaced. So now total 19 only, 4 defective and 15 non-defective bulbs. What is the probability that this bulb is not defective? When the second time is taking from the remaining bulbs from out of that, what is the probability of a non-defective bulb? So we can write here the non-defective means 15 are there. 15 by total is coming 19 only. So 15 by 90. Question number 18. A box contains 90 discs which are numbered from 1 to 90. So we can write that as from 1 to 90 are the outcomes. Number of discs. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number. We know that from 1 to 3 up to 9 that is single digit number, and remaining all from 10, 11, 12 etc. up to 90 that are 2-digit number. So to get a 2-digit number, there are total 81, total 90, from that we have to minus 9. So the remaining, that means 81 numbers are 2-digit. So 81 by 90. Which is equal to 9 by 10. Then second, what is the probability to get a perfect square number? Here we know that the perfect squares that 1, 4, 9, then 16, 25, 36, 49, 64, 81. So here we are getting 9 numbers. 9 perfect squares are there, 9 numbers. So to get a perfect square means these numbers from the out of this 90. 9 by 90. It is equal to 1 by 10. So to get a perfect square number from this, that is 1 by 10. Then a number divisible by 5, that means multiple of 5. 5, 10, 15, etc. up to 90, 85, 90. So total it will come 80 numbers. So 80 numbers, total is 90, which is equal to 1 by 5. A child has a die whose 6 faces show the letters as given below. The die is thrown once. What is the probability of getting A? Total number of outcomes 6. Out of that, 2 times A is there. 2 faces with A. So probability of getting the letter A is 2 by 6. 2 by 6, which is equal to 1 by 3. Then probability of getting the letter D only 1 time. So we can write 1 by 6. Question number 20. Suppose you drop a die at random on the rectangular region as shown in figure 14.6. What is the probability that it will land inside the circle with diameter 1 meter? So first we can find the area of the rectangle and circle separate. So area of the rectangle. Area of the rectangle, we know that length into breadth. Here it is given that as 3 meter and 2 meter. 3 meter into 2 meter is equal to 6 meter square. Then area of the circle. Pi r square. Here radius is given, diameter is 1 meter, which means radius is half of that 1 by 2 meter, half meter. So pi into radius we can take that as 1 by 2 meter or 0.5. 0.5. So that much meter. So we can take in fraction 1 by 2 into 1 by 2 r square, which is equal to pi by 4. Now find the probability that it will land inside the circle. That means area of the circle divided by area of the rectangle. So probability of getting the die drops inside the circle. Inside the circle is equal to probability to the die drops inside the circle, which is equal to here area of the circle, that is pi by 4. That divided by total area of the rectangle, which is equal to pi by 4 into the 6 is in the denominator. It's equal to pi by 24. Diameter 1 meter, which implies radius is equal to 1 by 2 meter. So probability of the die drops inside the circle is equal to probability area of the circle divided by total area of that rectangle. Probability is pi by 24. Question number 21. A lot consists of 144 ball pens, of which 20 are defective and the others are good. So total number of ball pens 144, defective ones 20, therefore good ones 144 minus 20, that is 124. Now Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that first part, she will buy it? She will buy it means the probability of getting a good pen. If it is good, then she will buy. So we can write the probability of getting a good pen, which is same as is equal to probability of buying, or the chance to buy the pen. So getting a good pen. Here total 144 pens are there, good ones 124. So we can write good ones 124 by the total 144, which is equal to 31 by 36. That is the probability to buy a pen. Then second part, she will not buy it. That means if it is a defective one, she will not buy. So probability of getting a defective pen, which means probability of not buying. So defective pens here 20 are there. 20 divided by total number is 144. So 20 by 144 is equal to, when we are simplifying, 5 by 36. So the probability of not buying, that is 5 by 36. Question number 22, refer example 13.1 and complete the following table. For that, we have to write all the outcomes. When two dice are drawing, here 1, 1, 1, 2, 1, 3 up to 1, 6. That means the first die with the face 1 and second die all that 6 chances or 6 cases. Then second same way, 2, 1 means first die on top, that is 2, and second die with a 1, 2, 3 up to 6. Like that way, all together 6 into 6, 36 outcomes are there. Total outcomes that it will come, 6 into 6 is equal to 36 outcomes are there. Now here to complete the table, we have to find the sum. Sum as 3. Here we can see 1 plus 2, that is 3, and here 2, 1. 1, 2, 2, 1. This one. That's 3. Then sum as 4. 1, 3, 2, 2, 3, 1. So each one we can see here how many pairs are getting. According to that we can complete the table. Sum is 3, that means 2. So we can write here 2 by 36. Sum is 4. 3 are there. So 3 by 36. 5. 4 are there. So 4 by 36. Then 6. 1, 2, 3, 4, 5. 5 are there. So 5 by 36. Then 7. 6 are there. 6 by 36. Same way for 9. 4 are there. So 4 by 36. And 10, 3 are there, 3 by 36. And 11, 2 are there, so 2 by 36. This we can write in simplified form. 2 by 36 as 1 by 18. Here divide by 3, then we will get 1 by 12. Here by 4, 1 by 9. That is same as that. Here 1 by 6. Here by 1 by 9. Here 1 by 12. 1 by 80. So completed the table. Now second part of that question, a student argues that there are 11 possible outcomes from here till here. 11 possible outcomes are there, and therefore each of them has the probability 1 by 11. Do you agree with this argument? Justify your answer. So we cannot agree. No, because the outcomes are 11 different sum. They are not equally likely. That means to get the sum as 3, probability is 2 by 36. To sum as 7, to get 7 as the sum of 2 dice, that is the probability here 6 by 36. So probabilities are not equally likely, different probabilities to get each number. Therefore we cannot agree with that. The reason is they are not equally likely. A game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. So the total outcomes we are getting 3h, 3 times always that h or always the tail, then head, head, tail, head, tail, head, tail, head, head, tail, tail, then tail ht, then tth. That means total 8 outcomes are there. 8 outcomes. Then here it's given Hanif wins if all the tosses give the same result. That means 3 heads or 3 tails. Otherwise he will lose. And loses otherwise. Calculate the probability that Hanif will lose the game. So Hanif loses if he does not get this triple H or triple tail. Rest of that all, any one of these if he is getting, he will lose. So probability of losing the game means out of these 8, to win the chance only these 2. So remaining 6 are there. So 6 by total outcome, that is 8, which is equal to 3 by 4. That is the probability of losing the game. Question number 24. A die is thrown twice. What is the probability that 5 will not come up either time and 5 can come up at least once? Throwing a die twice and throwing 2 dice simultaneously are same meaning. So here we know that when we are drawing 2 dice, we will get total 36 outcomes. And here the first part of the question, probability of not getting 5 either time. So we have to remove 5. Wherever that 5, that we have to count and remove. If we are taking this side, we can see 6 pairs are there. And here 4 plus 1. This already counted. Plus 1. So 6 plus 5, 11 places. That means or 11 options are there. 5 is coming up. Question is here 5 will not come up. So 5 will not come up means total 36 are there. 36 minus 11, 25. That means 25 pairs are here without the number 5. So probability is equal to that 25 by 36. Total is 36. So 25 by 36. Second part, 5 will come up at least once. At least once means we can take here this at least 1 and this also 2 times, but at least once minimum 1 time. So this also we can take it. So 11 places. Already we got that as 11 places 5 are there. So probability of getting 5 at least once is equal to 11 out of 36. Question number 25. In which of the following arguments are correct and which are not correct? Give reasons for your answer. First one. If 2 coins are tossed simultaneously, there are 3 possible outcomes. 2 heads, 2 tails, or 1 of each. Therefore, for each of these outcomes, the probability is 1 by 3. So we know that total possible outcomes when 2 coins are tossing, that is 4. 2 heads, 2 tails, head, tail, tail, head. Then probability of getting 2 heads, that is out of 4, 1 chance, so 1 by 4. Of getting 2 tails, that also 1 by 4. Then probability of getting 1 head and 1 tail. Here 2 are there. So 2 by 4, which is equal to 1 by 2. Here we can see the probability of getting 2 heads 1 by 4, 2 tails also 1 by 4. But 1 head and 1 tail is 1 by 2. Not equal to 1 by 3. So this argument is incorrect. It's wrong argument. Second case, if a die is thrown, there are 2 possible outcomes, an odd number and even number. Therefore, the probability of getting an odd number is 1 by 2. Total possible outcomes when the die is throwing 1, 2, 3, 4, 5, 6. These are the numbers on the dice. So total possible outcomes, that is 6. Then out of these 6 numbers, getting an odd number, 3 odd numbers are there, 1, 3, 5. So 3 by total number is 6, 3 by 6, 1 by 2. And same way getting an even number, 2, 4, 6. That also 3 by 6, 1 by 2. Both the case probability is same to get an odd number and even number. Hence this argument is correct. This argument is correct and the first one is wrong.